Okay, so yeah, before moving forward, as you requested to discuss some inequalities, okay? So yeah, so first 10 to 20 minutes I will talk about the inequalities. Okay, then we will move to the limit evaluation. Okay, so yeah, let's start. So the first, oh, okay. Okay, so as you know that if function is modulus function, then its property is mod x will be equal to x if x is greater or equal to 0, and it will be minus x if x is less than 0. Okay. Oh, someone is asking something. Mic is off? No, I'm audible to everyone, right? Hello? Yes. Okay. Check your speaker. Okay. Oh yeah. So let's suppose, yeah, it's this is the modulus function. So the value of y will be x if x is positive, and it will be minus x if x is negative. For example, if you have function like this, so its property will be x minus 1 if x minus 1 is greater or equal to 0, and its value will be x minus of x minus 1 if x minus 1 is less than 0. Okay, so yeah, so this was the first property of the modulus. Now second property is, what if mod of x equal to a, then what is the solution? Okay, if a is greater or equal to 0, then its solution will be x belongs to minus a to a. This is not a set, it's a set, but the thing is this is the element. Okay, so it has only two solution, either x has to be minus 1 or x has to be plus 1 if a is greater or equal to 0. But what if a is less than 0? Okay, then what will be the solution? Tell me. Here if a is positive, then the solution will be minus a or plus a. If a is negative, then what will be the solution? Suppose mod of x equal to minus 1, then what is the possible values of x? It will not produce any values, because modulus of x is always a positive number. So which means that whatever you are trying to feed at the place of x, it will always produce positive number, but it is saying the modulus of x should be minus 1, which means that it will not give, so there will be no solution. Okay, now if mod of x is less than or equal to a, if a is positive number, so in this case, since this is an inequality, which means that the solution will be not just an element, the solution will be a set. Okay, but here it is a equality, there is a equal sign, which means that the solution will be some numbers. Okay, some number of solutions, but here the solution will be a set, so which means that there will be infinite number of solutions. But here, if a is greater and equal to 0, which means that if a is positive number, then solution will be x belongs to minus a to plus a. So here there is a square bracket, which means that I am including a also. Okay, if suppose something is like this, so which means that I am not including minus a, but I am including plus a. So yeah, so this convention you have to follow here. Now if a is positive, then this is the solution. But what if a is, if a is less than 0, what will be the solution? Tell me. Okay, you can
For 0 it will be solution. For less than 0 it has not solution.
what will be the solution if a is less than 0 in this case? You can also interpret like this. This is the graph of mod x, right? Now if a is positive number, which means that the graph of y equal to a will be below the x-axis. Okay, now I'm asking mod of x should be less than n equal to a. So you can see that mod of x, for every x, mod of x is always positive, positive to the y equal to a line. So which means that you will never get a solution to this inequality if a is less than or equal to 0. Okay, so in this case there will be no solution. But in this case, suppose if a was positive number, if a was a positive number and this was the mod x, if a was positive number, which means that the y equal to a line will definitely intersect. Okay, now I'm asking at what x such that mod of x will be less than a. So you have to find such x where mod of x will be less than a. So in this domain, you can see that mod of x is always larger than y equal to a. In this domain, you can see that mod of x is always larger than a. But in this domain, this line will be plus a and this is minus a. When y equal to a intersects mod of x, then point of intersection will be minus a and plus a. But in between minus a to plus a, you can see that mod of x is always below than y equal to a, which means that the domain of x, the solution set, will always be in between minus a to plus a. That's why we are getting this solution. But in this case, we are not getting the solution. It's fine? Tell me.
Yes.
Okay, so let's, if mod of x is greater or equal to a, if a is greater than 0, then what will be the solution set in this case? And if a is less than or equal to 0, then what will be the solution set? Here actually, if I'm considering, if I'm taking it, if I'm taking 0 also, then we have to remove the equality sign. Okay, in this case also, because I have already considered 0 in this case, so which means that I have to remove 0 in this, 0 here. Okay, now tell me what is the solution in this case if mod of x is greater or equal to a, if a is positive number? Tell me quickly. all these things are
0 to A.
0 to A. You might have studied all these things in your 11th and 12th. All these things are already in 11th and 12th standard. So you can see that mod of x will be always greater than 0 when the domain will be larger than a and smaller than a. So you can see that this line is nothing but the mod of x is always above to this y equal to a line. So which means that in this domain mod of x is always larger than a, and in this case also mod of x is always larger than y equal to a. So which means that the solution set will be minus infinity to minus a union a to infinity. So a to infinity means whatever the x after this, and minus infinity to minus a means whatever the x below this. So that's why this is the solution. But if a is less than 0, so I will consider this case. You can see that if a is less than 0, which means that y equal to a line will always be below the x-axis. Now the inequality is asking at what x when mod of x is always greater than a. So you can see that mod of x is always greater than y equal to a, whatever you put the value of x. So which means that x belongs to all real number. In this case the solution will be all real number. Whatever you will put x here, that will give the solution if a is negative. Fine? Tell me.
Yes, sir.
Yeah, okay. Now I will ask one more question. If a is greater than 0, okay, now I have an equality like this, then what is the solution set? If a is greater than 0, and I have equation x square is less than a square, then what is the solution set? Here I can also write it as mod of x is less than a. This equation is nothing but this. This equation implies that this, which means that the solution set will be what? Minus a2 plus a. Okay, I have already, so yeah. But what if a is less than 0 and I have the same equation? So in this case also I can write this. Is this correct or not? I can write this or not? Apply your intuitions. See, it is very easy to interpret. Here I have the inequality x square is less than a square. Okay, so yeah, so this is the y equal to x square graph. Okay, y equal to x square graph. Now since a is positive, okay, since a is positive, which means that this y equal to a square will always be above the x-axis. So this is the line y equal to a square, and you can see that this point is nothing but x equal to minus a and x equal to plus a. Now I am asking what is the solution for x if x square is always below than a square. So where is the set where x square is below than y equal to a square? You can see that in this region this y equal to x square is always below than y equal to a square. So which means that solution set is nothing but minus a to a. So this thing I can also write this. So this equation is equivalent to this. Now I am asking if a is less than 0, then you can see that even if a is less than 0, this square will make it positive. Still the same equation will hold. So again you can write it as minus a to a. Fine? Tell me.
Yes, sir.
If a is greater or equal to 0, now I have this equation. Then what will be the solution? You have to find your own way. I will not always teach you what you have to do. It's just like I'm spoon feeding. But you have to apply your brain. You have to find your own way. How you will solve this. I will not always teach you like you have to do this, then you will get the solution. Solve this. What will be the solution?
So, sir.
Yeah.
Sir, x square is less than equal to a square. From this, sir, how you write mod of x is less than equal to a?
This is nothing but equivalent to this. Whatever the solution of this will be exactly equal to the solution of this inequality. So that's why I am writing that this is equivalent to this. You can always write it. If x square is less than a square, which means that mod of x is less than a. The solution will always be like this. Fine? These two equations are equivalent.
Yes, sir.
Okay? Yeah. What is the solution of this? In this case, what is the equivalent equation? This is the equivalent equation. Then what is the solution? X must be this union a to infinity. If you want to remember, you can also write x is greater than a or x is less than minus a. These two are same. Whenever you see the inequality is less than, which means that the solution will be in between, and whenever you see the inequality is larger, the solution will be apart from the in between. So this is nothing but the apart from the in between. Okay, but what if a is less than 0? What is the solution of this equation? What is the solution? I have already drawn this, right?
0 to infinity.
So minus infinity to minus a union a
Yes.
and infinity.
Yeah. This equation is nothing but this. Exactly, these two are same. Because even if a is less than 0, if you make it a square, these two are equivalent. So which means that this equation is nothing but mod of x is greater than a, and the solution will be this. Fine? Okay. Now tell me, at what condition mod of x plus y will be exactly equal to mod of x plus mod of y? In which situation I can write? What will be the situation? I mean, what is the condition for x and y such that mod of x plus y will be exactly equal to mod of x plus mod of y. At what condition? Just think about it. X and y can be any real number. Now just tell me what is the solution. What kind of x and y I will put there such that it will satisfy this equation.
X and Y both should be greater than 0 or equal to 0.
Yes, great. Yeah. So let me prove this. Just square both side, okay? Okay. So the modulus of a square is exactly equal to without modulus of that square, which means that this will be x square plus y square plus 2xy. And here again this is x plus y raised to the power square. Okay. So this will be am I doing wrong here? X plus y raised to the power 2. Yeah, okay. So this will be nothing but a plus b raised to the power 2. So that will be mod of x raised to the power 2 mod of y raised to the power 2 plus 2 times mod of x mod of y. Okay, then you can see that these two terms will be cancelled out. Now you will get xy minus mod of x mod of y is equal to 0. So here you can see that this equation will be satisfied only when x and y is always greater or equal to 0, which means that the solution will be either x, y greater or equal to 0 or x both will be less than 0. Yeah, okay. So which means that if both are positive, then this equation will be satisfied. If both are negative, then this will be satisfied. But suppose if x is positive and y is negative, then this equation will not satisfy. Okay, so this is the solution. It's fine. Tell me. Okay, so let's move forward. So there are two more inequalities like this. If x plus y is always less than or equal to mod x plus mod y, this is also called triangular law of inequality, triangle inequality. And x plus minus y will always be greater or equal to mod of x plus minus mod of y. Okay, these two are, it's not important for GATE perspective, but yeah, you have to remember this. Okay, now let's take some example of inequality, how we can solve this. So suppose I have an inequality like this, and I have a question: solve for x. Solve this very quickly. What is the solution? Okay. What is the answer? Tell me. Okay. So you can see that it has two inequalities. This is first and this is second. Either you can use this way or graphically you can solve this very easily. Okay, so yeah, let's take this first inequality, that is nothing but mod of x plus 1 is greater or equal to 1. This is the first inequality, right? Is this correct? I have just inverted that. Is this correct? I can write this as this, right? Tell me.
Yes, sir.
Yeah. Okay. So what is the solution of this? I can write x plus 1 is what? Greater than or equal to 1, or x plus 1 greater or equal to minus 1, right? So here I will get x must be greater than 0, or here you can see that I will get x must be less than minus 2. This is first solution set. Now let's talk about the second inequality, that is mod of x plus 1 is less than 3. So the solution of this is nothing but x plus 1 will always be less than or equal to minus 3 to 3. Okay, so yeah, add both side by minus 1, you will get fine. So this will be minus 4, this will be x, this will be 2. So the first set was this and this was second set. Now use the number line method. So number line method, you have to plot all those zeros. So the first zeros is 0. Second 0 is x equal to minus 2. Third 0 is 2. Fourth 0 is minus 4. Sorry, yeah, minus 4 will be this side. Okay, so I have plotted all zeros on this number line. Now the first set is saying that x must be greater or equal to 0. So which means that the solution set will be x must be greater or equal to 0. So solution set will be along this side including 0 also. Now the second set is saying that x must be less than or equal to minus 2, which means that here x equal to minus 2, which means that it is saying that solution set will be along this direction. Now this set is saying x must be in between minus 4 to 2. So here minus 4 and here 2. The solution set will be like this. So after using all these set, you have to get one intersection set. So you can see that the intersection of these three will be nothing but this set. Are you able to see? This is saying it should be greater than 0. This is saying it should be less than minus 2. And this one is saying in between 4 to minus 4 to 2. So the solution set will be in between these, such that all these three solution set will be satisfied. Okay, so which means that overall the solution will be what? Minus 4 to minus 2 union 0 to 2. So this is the final solution set. It's fine. Tell me.
Sir, I didn't understand the second part, second equation.
Second equation. Okay, so I told you, right, if mod of x is less than equal to a, the solution will be x will be in between minus a to a, right? So I use that identity. So you can see that at the place of x it is x plus 1. So the solution will be minus 3 to 3. Now add minus 1 on both sides. So this will be minus 1 and minus 1. So this will be cancelled out. This will be -4. This will be 2. So which means that the solution of this inequality will be in between -4 to 2. So that's why you get this solution set. It's fine.
Okay, sir.
Is there any doubt here? You can also get this solution graphically. Okay, first I will talk about the graphical transformation, then I will talk about this all things. Okay, so let's move to the graphical transformation. You can use this utility. Okay, yeah, so let's talk about first case. If I want to change fx to fx plus minus a, so suppose, so this is the first graphical transformation I want to change, which means that suppose you have some graph like this, and this is the graph of function fx. Now based on this I want to draw the graph fx plus minus a. So here there is a condition if a is positive number. Okay, so if you want to draw this, then you have to do one thing, just translate this graph by a unit above or below based on the sign of a. So you can see that if this is fx, then the graph of fx will be nothing but, sorry, graph of fx plus a will be this, fx plus a will be this, and the graph of fx minus a will be this. So this is the graph of fx minus a. So this is nothing but the vertical translation. This is what? Vertical translation. Okay, yeah, so now let's talk about second transformation. The second transformation is, yeah, let's take one, yeah, okay, let's take a second example. If you want to transform this function as this, instead of adding in the function as a plus a, now I am doing is I am adding a plus minus a in a. For example, suppose initial function is sin x, then you want to transform this sin x plus minus a. But here it is different. Here if initially it is sin x, then you want to transform this like this, sin x plus minus a. So these two are very different. Okay, so yeah, so how you will transform this? Suppose you have a function like this. Okay, this is the function. Now transform this like this, fx plus minus a. Then you have to translate. If you want to use a transformation of this function, then you have to translate along the x-axis by a unit. Initially it was at the origin, now it has shifted at a unit, and this is the function that is fx minus a. Okay, so you have to very careful here. If you are subtracting a by a unit, then it will move in right direction, but if you are if you are adding a, then it will be in left direction. So this is the a unit. Okay, now this function is nothing but the fx plus a. So you can see the difference. Okay, so this graph has shifted in right direction, but this graph has shifted in left direction by a unit. So for example, suppose you have a graph of sin x. Okay, this is the graph of y equal to sine x. Now someone wants to draw y equal to sine pi by 2 plus x. So you can see that it will shift in which direction, left or right? Left direction. Okay, just by pi by 2. What is the coordinate of this point? Pi, right? This is pi, this is minus pi. If you shift this in pi by 2, which means that this point will be here. So this will be something like this. So this is what? Y equal to sine pi by 2 plus x. Okay, so in this case we are doing horizontal translation. Horizontal translation. Okay, now let's talk about third case. If I want to transform fx to a times fx, so in this case, suppose you have a function like this. So this is the function fx. So if you transform it a times fx, then what it will do is it will just amplify this height, whatever this is. Zeros will remain same, all zeros will remain same, but it will be stretched by a times in vertical direction. Suppose initially it was 1, so after using this transformation, this will becomes a, vertical height will become a, so this will be a, but zeros will remain same. Suppose initially it was pi, then it will remain pi. Yeah, so this is nothing but the vertical stretch.
In the previous example, in the sine example, the independent variable was shifting in sine x,
Yes,
and in this current example, the dependent variable is shifting.
no, yeah, you can say that. Yes, fine.
Yes.
Yeah, so this is the example of vertical stretch, or you can also say compress. Suppose if a is greater than a, if a is greater than 1, so which means that it will stretch. But if a is in between 0 to 1, again zeros will remain same, but it will be compressed. Suppose earlier it was 1, now it will be something like this. It has compressed. So this is the graph. This is again the graph of a times fx, but again it has been compressed because this a is in between 0 to 1. Okay, yeah, so let's take another case. Fx will change to fx a times x. Okay, so yeah, in this case, suppose again I will take the same example, sin x. Okay, so this is the graph of y equal to sin x. Now I want to transform it as y equal to sin a x. Okay, so in this case what will happen? Similarly, in this case, when you multiply with x, it will be compressed. It will be compressed, but in horizontal direction. Suppose earlier it was at point A. Now if A equal to 2, then what will happen is height will remain same. Vertical height will remain same, but this graph will be compressed but in horizontal direction. So yeah, the graph will be something like this. Now can you tell me what is the coordinate of this? What is the coordinate of this? If a equal to 2, which means that this function has become sine 2x. So which means that you can see that this horizontal compression, so this pi will become pi by 2. So that's why it will become pi by 2. So which means that this function will be become 0 at first 0, it will be at pi by 2. So this is nothing but the horizontal stretch and compression. Stretch slash compression. But you have to remember, if you increase a, that will compress, but if you decrease a, and yeah, one more thing, a can be either greater than 0, can be either greater than 1, or a can be in 0 to 1. That is another case if I do like minus a, so that is another transformation. Okay, but here I'm considering if a is greater than 1 and a is in between 0 to 1. So the stretch will be when a is 0 to 1, but when a is greater than 1, then there will be horizontal compression. It's fine? Tell me.
Yes.
Yeah. Now let's move to another case. If I want to change fx to minus fx, then what will happen? Okay, so consider I have a graph like this. Okay, this is the graph of fx. Now you can see that I want to change as minus of fx. Then what will happen? You can see this. You see that the value of y has become just minus times of that initial y, which means that whatever earlier it was taking as x and it was giving the output, now output has been reverted in positive direction. So which means that there will be no change here, because here y is already positive. It's fine.
Yes.
Okay, but this has changed like this.
Sir, graph will reverse, no, sir? This is also reverse.
Yeah, that's what I'm asking. That's what I want to ask. Is this correct or not?
Yes, sir.
This one?
Reverse, sir. It will be a reverse.
Yes. This will also change. Okay, so the graph will be like this. Fine. Earlier it was like this, now it is like this. Then what happened? What exactly happened? What exactly happened? Mirror about x-axis, right? So this transformation is nothing but the mirror about x-axis. Just take the mirror image about x-axis. So you will get that transformation. It's fine. Now I want to change fx to f of minus x. Then what kind of transformation will be this time? Tell me. Suppose earlier graph was like this. Now I have transformed this f of minus x. Then what kind of transformation will be? How it will be transformed? This time there will be vertical mirror image. Earlier it was like this, now it will be like this. So it will be vertical image. Okay, earlier it was like this. This was fx, now this is f of minus x. So which means that mirror image about y-axis. It's fine. Now I want to change fx to mod of fx. Then what will happen in this case? And the graph is something like this. This is the graph of fx. Now I want to change it to mod of fx. Then what will happen? In this case you have to just reflect
Sir, this negative part will up.
reflect the graph which are below the x-axis. So which means that you can see that this was the graph which was below the x-axis. So which means that you have to just reflect it about x-axis. Graph about x-axis. Okay, so you will get graph like this. So this is the graph of mod of fx. Let's take an example. Suppose you have the graph of e raised to the power x. This is the graph of e raised to the power x. Now I want to change it to mod of e raised to the power x. But in this case there will be no effect because e raised to the power x is always positive. Let's take this example. This is the graph of y equal to ln x. Now I want to change it to mod of ln x. Then what will happen? This part will remain exactly same, but this part will be reflected. Okay. Now take case h. If I want to change fx to mod of f of mod x, then what will happen? I'm taking the same case, this y equal to ln x. Now I want to change it to ln mod of x, then what will happen? Tell me, what will happen?
Graph will remain same.
What? Graph will remain same. Think about it. Yes, you are right. In this case, graph will remain same, because here you can see that there is no such x where it can take negative, right? So whatever you take, I mean, the thing is, in this case, x is by default will be always greater than 0 in this case only. So which means that there will be no transformation. Yeah, so that's why you have to take another example. No transformation. In this case, there will be no transformation. So first I will erase this directly, because in this case there is no transformation. Take this one, sin x. What will happen in this case? Whatever it is showing the graph along negative x direction, it will show exactly same whatever it is in the positive direction. So which means that this will remain same, but this graph will not remain same. This portion will not remain same, which means that it will show the property will be something like this. Whatever the graph was in this area will be exactly replicated in this zone, because you can see that it will show the same property as when x is positive or negative. So that's why there will be mirror image. Mirror image of positive x axis portion in the negative portion, negative x axis. Are you getting what I am trying to say? Tell me.
Sir,
Yeah.
since the graph is symmetric along y-axis also, it will be inverted in the y-axis, or
Where it is symmetric about y-axis? There is no symmetric about y-axis. In this case, there is no symmetric about y-axis. But yeah, cos x is symmetric about y-axis. That's why the graph of cos x or graph of cos of mod x is exactly same. Here sin x is not symmetric about y-axis. Symmetric about y-axis means function is even. In this case, sin x is not an even function. Sin x is actually odd function. So whatever it will show the value at x, it will be just negative times of it will show at the value of minus x. So there is no symmetric about y-axis here. Fine?
yes.
Yeah. So this was all about the symmetricity, graph. Now take this transformation as an advantage to solve this problem. This one. Let's solve this. How we can solve this one? So what I know is this is the graph of mod x. Okay, this is the graph of mod of x. Now I need mod of x plus 1. What will happen then in that case? In that case, what will happen if I want to draw mod of x plus 1? What will happen? I want to solve this inequality using the graph. This is the graph of mod x. Now I want to ask what is the graph of mod of x plus 1. Tell me.
The graph will shift by a unit place towards the left.
Okay, in left or right?
In left.
Left. Great. So yeah, so this is the graph of by 1 unit. Earlier it was at the origin, now it has shifted horizon time, it translated by 1 unit. So this is the coordinate 1 comma minus 1 comma 0. What is the coordinate of this point? What will be the coordinate of this point? What is the equation of this line? Can you tell me what is the equation of this line? Okay, what is the angle of this line?
So y equal to x.
Y equal to x? No. What is the slope of this line? What is the slope of this line?
45.
Oh my god. Slope can never be an angle.
1 by root.
1.
1. Slope is actually tan theta. If someone is asking what is the slope, you cannot say the angle. Okay. Now, what is the slope of this line? This line.
1.
1. Exactly, because it has been translated. Okay. So, then what is the equation of this line? Can someone tell me what is the equation of this line? If slope is 1, which means that this angle is 45, which means that if this length is 1, then this length is also 1. So you can see that I can directly say that the equation of the line, that is nothing but y equal to x, and since y-intercept is 1, so y equal to x plus 1. Now what is the equation of this line? What is the slope of this line?
Minus 1.
1.
Minus 1. 1, not 1, minus 1. So what is the equation of this line? Y equal to?
Minus 1.
Equation. I am asking equation. What is the equation of this line?
X minus 1.
X minus 1. Then how the slope will be minus 1? Minus x minus 1. That's why the slope of this line is minus 1. Since this is the intercept, you can see that the y-intercept of this line is nothing but the minus 1. So this is the equation of this line. These things are very fundamental. You guys already forgot why it is happening. You guys are not reading at all. These things are very, very, very fundamental. You guys are doing engineering. What's going on? Okay, so yeah, now I want to solve this inequality. I already drawn the graph of this function. Now it is saying that I have to draw y equal to 1 line. So y equal to 1 line will be exactly at here. So this is the y equal to 1 line. Now I have to also draw y equal to 3 line. So y equal to 3 line will be here. So this will be y equal to 3 line. Now it is asking at what x such that mod of x plus 1 will be always in between 1 to 3. So what is the zone where mod of x plus 1 is in between 1 to 3? So you can see that this is the zone. This is the zone. This is the zone where mod of x plus 1, this is the graph of mod of x plus 1, this is the graph of mod of x plus 1, which are in between y equal to 3 and y equal to 1. So which means that the domain, the solution set will be this, and the solution set will be this. Now you have to find the coordinate. So you can see that what were the solution? 0 to 2. When you find the coordinate, this coordinate is nothing but x equal to 2, and this coordinate will be -4 and -2. So we can see that x belongs to -4 to -2 and 0 to 2. It's very time saving, but
So,
because of the explanation it took so much time, but you can easily solve that equation. Yeah, tell me.
so in the question, if the function is mod x plus 1,
Yes.
so for this question only, so the answer should be only 0 to 2, because the equation which is asking in the question is only mod x plus 1, not mod minus x minus 1.
Why? I'm not getting
So,
your question. What is your doubt exactly?
so according to the graph,
Hmm.
and the question asked, that is mod x plus 1, right?
Yes.
And for that equation, the solutions would be only 0 to 2.
Why 0 to 2?
So because the equation of the line which is asking the question is only mod x plus 1, not mod minus x minus 1, right?
You are complicating things, but the thing is the solution is not violating this equation. I'm getting what you are trying to say, but the thing is there is no such domain of mod of x. What is the domain of mod of x plus 1? Can you tell me? If you have a function fx equal to mod of x plus 1, what is the domain of this? Tell me.
1 2 3, I think.
1 2 3.
That is minus, that is less than 1, and greater, sorry, less.
All real numbers.
All real numbers. What is the definition of domain?
Okay, yeah.
What is the definition? Domain says for such x where the function is defined, that's it. But in the case of mod of x plus 1, there is no such violation. Now suppose if it was ln x plus 1, then you can see that the domain should be always x greater than -1. So in this case you can put that restriction that whatever the solution you are getting, that should be greater than 1. But again, this restriction, if you are using the graph, there is no such use of that restriction, because in graph that restriction will always be there. But suppose you are solving that inequality algebraically, then you have to put that restriction after solving that. But in the graph there will be no use, because that restriction will be always taken care of that graph. Okay, suppose if someone is solving ln x plus 1 is greater than greater than 0, then you can see that if you draw this graph ln x plus 1, this is the ln x. Okay, now what is the ln x plus 1? What is this point? This is ln x. What is this point? E, right? Now shift this by 1 unit. So this will be something like this. This will be ln x plus 1. Now someone is asking, I want to ask such as x where ln x plus 1 is always greater than 0. So earlier it was e, now it has been shifted left, so this will be e minus 1. So the solution will be e must be greater than e minus 1. So this is the solution. Then you can see that this is that restriction, that x plus 1 is always must be greater than 0. It always been taken care, has always been taken care. If you are solving any kind of equation, inequality graphically, that restriction will always be taken care. But if you are solving that algebraically, then you have to take care that domain. It's fine. Tell me. Tell me it's fine or not.
Yes, sir.
Okay, great. Now I will move to the some logarithmic properties. Okay, so the first property is, it is saying log of base e of a times b will be log of to the base e a plus log of to the base e b. What is the condition to use this? Kalpana, tell me when I can use this. When I can use this. So I can use this property when this base is always positive. But since here e is always greater than 1, this value is lying in between 2 to 3. So there is no any problem here. But here there is a restriction. That restriction is a and b should always be a positive number, and also a comma b cannot be equal to 1. So this is the restriction. So which means that a and b both has to be a positive number, and also a and b cannot be equal to, not 1, here 0. So this is this is always been taken care. So yeah, there is no use of that. So yeah, so here a and b should always be greater than 0. Okay, now in this case also, what is the restriction? Again, a and b should always be greater than 0. Here, what is the restriction? Again, a should always be greater than 0. Now let's talk about fourth property. Log of a to the base a is, what is the value?
1.
1. And what is the restriction? A should always be greater than 0, and a cannot be equal to 1. In this case, you have to be very careful. The base of the logarithmic function cannot be equal to 1. Again, I am repeating, the base of logarithmic function cannot be equal to 1. Okay. Fifth property. Log of a raised to the power m b will be equal to 1 by m log b to the base a. What is the restriction?
M greater than 0.
No, it's not necessary. M can also be less than 0.
M should not be 0.
M cannot be equal to 0, because when m becomes 0, this whole quantity will become 1, and here also you can see that m cannot be equal to 0. Fine. And what are other restrictions? B should be greater than 0, and also A cannot be equal to 1, and also A should be greater than 0. Fine.
Yes.
Sixth property.
So,
Yeah.
so what is the actual meaning of that base?
Base, what I can say the actual meaning of the base. Base is actually defined like this. Suppose you have an exponential function a raised to the power x equal to y. Okay, then this base is actually defined by x log a. Okay, and whatever the base it can be, it will be always equal to log of y. So here m can be in any number greater than 0, m cannot be equal to 0. So by using this definition, the base is defined. It's an axiom, I mean, there is no such definition. The thing is, on the basis of the base, actually log increasing.
Okay, sir.
Okay, because logarithmic function is an increasing function. Okay, suppose log of x base a, this is an increasing function, but log of x base a, if a is in between 0 to 1, this property will be something else, the graph will be something else. Graph will not be exactly this if a is in between 0 to 1. Can someone tell me what kind of graph it will be? Here it is sure that a is greater than 1. But if a is in between 0 to 1, then what kind of graph it will look like? If a is 0 to 1, which means that this is a
Negative.
fraction quantity, right? This will be a fraction. And if it is a fraction, which means that you can write something like this. Suppose b raised to the power minus 1, b raised to the power minus 2, something you can write it, right? If it is a fraction number. So that negative sign will come outside. So this thing is nothing but there is a transformation of log of x to minus of log of x. So the graph will be something like this. So the log of x graph is always like this when a is greater than 1. But if a is in between 0 to 1, graph will be like this. So which means that if a is greater than 1, if you increase x, the graph will be increasing. But if a is in between 0 to 1, if you increase x, the value of graph will be decreasing. So that is the thing you can think about it. Fine? Tell me.
Yes.
Now let's move forward. Sixth property. Log of a to the base b, it can also be written as 1 by log b to the base a. What is the restriction? A, b should always be greater than 0. A and b cannot be equal to 1. Seventh property. A log a m. Here a raised to the power log m to the base a. So that value will be m. And the restriction will be what? A cannot be equal to 1. A should always be greater than 0. M should also be greater than 0. Eighth property. This is very important. If log of x to the base m is greater than log of y to the base m, then there are two consequences. Can someone tell me? there is an equality. If log of x to the base m is greater or equal to log of y to the base m, then you can write x is greater or equal to y if m is greater than 1. But if, I mean, the solution of this will be x less than y if m is in between 0 to 1. Ninth property is very similar to that way. So if log a to the base m is greater than b, then it can be written as a greater than m raised to the power b if m is greater than 1, but it can be written a less than m raised to the power b if m is 0 to 1. This is all about the logarithmic properties. Now tell me if you have a doubt. Fine. Should I move to the limit? Should I continue?
So can you show the fifth property?
This one.
Okay, sir.
Fine. Should I move towards the limit? Tell me.
Yes, sir.
Yeah, okay. So now let's move to the evaluation of limit. Last time we talked about the continuity and the definition of limit. So we usually see this kind of limits and that we can solve it. That method is factorization. Factorization method. We usually see rationalization method. Third, we will see standard formula. Then we will see some trigonometric identities. Logarithmic limits. Exponential limits. These are the kind of limits. Exponential limits. And finally there will be miscellaneous. What is the spelling of the miscellaneous? I'm very bad. Okay, so these are the kind of limits. Okay, but yeah, one thing you can always apply, that is L hospital rule. Since you have to give gate, so it won't matter whether you are applying L hospital rule or you are applying all these identities or factorization, rationalization, whatever it is. Anyhow, you have to solve that limit. Okay, but one thing you have to be very careful. That is what? Can someone tell me? Before solving the limit, one thing you have to be very careful. What is that? That limit should exist. Fine. Without existing of the limit, you cannot find the limit, because when you solve for the left hand limit, you will get other answer. If you solve for the right hand limit, you will get another answer. So you may get wrong answer. So you have to be very careful. If you look at that options, if you are seeing that there is an option of limit doesn't exist, so then you have to be very careful at that point. If there are no such option, then fine. Okay. So L'Hospital rule says if the form is indeterminate, then limit x tends to a, if it is a form of fx divided by gx, then it will be exactly equal to limit x tends to a f dash x g dash x, and you have to continue this. You can also, if not indeterminate, if not indeterminate, then you have to again do the derivative, second derivative, and you have to do this until you get a finite value. Fine. This is the rule of the L'Hospital rule. I can also derive it. Why L'Hospital rule is true when the form is indeterminate, but the thing is I don't have time. Okay. So yeah, so let's take one example. Evaluate. Very easy. Just tell me answer. What is the answer?
-1.
Yes, it's correct. So there are many ways to solve this. I will do one by one, okay, because I want to explain everything. So the first method is factorization. Since you can see that it is 0 by 0 form, when you directly substitute this limit into this, you will get 0 by 0 form, that is indeterminate form. Okay, so yeah, first method is doing factorization. Just factorize it. The numerator will be x minus 1 and x minus 2 divided by x minus 1. This, since I cannot cancel it out, x minus 1, I cannot cancel it, but since it is approaching to 1, it's not exactly equal to 1. That's why I am cancelling this, okay? Otherwise I cannot cancel that. Now substitute that x, so that will be plus 1 minus 2, that will be minus 1. This is the first method. What is the second method? Apply L'Hospital rule, okay? So this is nothing but differentiate the numerator. So d by dx x square minus 3x plus 2 divided by d by dx of x minus 1. So you will get 2x minus 3 divided by 1. Now you can see that now this is not 0 by 0 form. Okay, so you can directly substitute limit. So that will be 2 into 1 minus 3. The answer will be minus 3. So this is the second way to do that.
Sir,
Yeah.
the denominator will be minus 1.
Denominator, why minus 1?
Yes, okay, sorry.
Okay, yeah. Okay, let's take another example. This one, yeah, another example. What will be the answer? Okay, what is this definition? Can someone tell me what is this definition? This is a kind of definition to get something.
Derivative.
Derivative of which function? Which function? Square root of x. Okay, so this is the way to find the derivative from the first principle. This is the first principle to get the derivative. Okay, what is the answer? Now, someone you can directly tell me what is the answer. What will be the answer? This is nothing but the derivative by square root of x.
Root h.
Huh? What?
Root h.
Root h? No. You are substituting h as h tends to 0. Then your answer cannot be in the form of h.
1 by 2 root x.
Yes. This will be the answer. Okay, but the thing is how we can solve this. Okay, so yeah, this is the another way to solve that. This is called rationalizing the denominator. If you multiply this by conjugate of this, so this will be nothing but a minus b into a plus b. So the thing is it will be a square plus b square. So that will be x plus h minus x divided by h, x plus h plus square root x. Now you can see that I don't have to check it. It is already a 0 by 0 form, right? 0 by 0. So that's what. Yeah. So x will be cancelled out, and again after cancelling, this h will also be cancelled out. Now substitute h here. So that will be x plus 0 plus, yeah. So that will be this. So this is the way to get the limit of this. Now this was the first method. Now let's, yeah, this was the first. What will be the second method? Just differentiate that. With respect to what? I have to differentiate this numerator and denominator with respect to what? X or h? What is the variable here?
H. H.
H, not x. You have to be very careful here. Here the variable is not x, the variable is h. Okay, now differentiate this. The derivative of the numerator will be 1 by 2 x plus h. Okay, and this will be 0 and this will be 1. Directly just substitute h 0, you will get 1 by 2 square root x. Okay, yeah, now let's move to one standard formula, that is limit x tends to a, x raised to the power n minus a raised to the power n divided by x minus a will be actually equal to n minus 1. This is the very standard formula. Okay, so yeah, this problem can also be solved by this, using this. So you can see that here at the place of, yeah, tell me what is there, is there any problem?
So we will be looking for for the hospital rule. We need to check whether the option will be given limit does not exist. That's the only failure criteria that we need to check.
Limit whether it will exist or not.
Yes, in the option.
That is the temporary solution, but the thing is, whatever I am talking here, all those limits are already existing. You can check that all those limits are already existing, that's why we are able to find it. Okay, I'm not saying that I'm just skipping. You can check that all these limits are already existing, that's why I am finding it. Fine, but you have personally, you have to be very careful in exam. I showed one case where it seems that it will exist but limit doesn't exist at that time. Fine, that's why I'm telling that is a trick. If there is an option that limit does not exist, then you have to be very careful there, because this kind of problem here, you can see that this kind of problem, you cannot say that whether limit will exist or not, you have to check. But in shorter time, if there is an option that limit does not exist, then you have to be very careful there. Anyhow, if you check the limit whether it is existing or not, you will get the answer at that time only. If you check whether limit is existing or not, you can get the answer that time only, right? You don't have to do all this. If you check the limit whether it is existing or not, during that you can get the answer. Am I right or not? At that time only you are getting the answer. In the previous section you can see that. Yeah, so okay, all those examples are for the does not exist. Okay, yeah, suppose I'm taking this example. You can see that you are not only checking the limit, but you are also solving the limit. If it exists, which means that you will get both sides will be equal. If LHS is equal to RHS, then what is the value of this limit? That will be, suppose both are 1, the value of the limit will be 1. That is the answer. So you don't have to evaluate the limit again. That is already your answer. Fine. Okay, let's take another example. Find the limit of this. What is the answer? You cannot apply L hospital rule here. Okay, so let's start from the very fundamental. What will I do is I will try to cancel out terms. So you can see that this term can also be written as n plus 2 times n plus 1 factorial. Okay, and this one can be written as it is. And here in this case also I can write n plus 2 times n plus 1 factorial minus n plus 1 factorial. Now take common of n plus 1 factorial both side. You will get n plus 2 plus 1, and in the denominator also you can take n plus 1 factorial common, and you will get n plus 2 minus 1. Now I can cancel it, n plus 1 factorial, n plus 1 factorial. Now the expression will be n plus 3 divided by n plus 1. Now what will I do is I will take common of n in numerator and denominator. Then you can see that it will become nothing but 1 plus 3 by n and 1 plus 1 by n. Okay, so you can see that if n is approaching infinity, then 3 by n will approach to 0 and 1 by n will approach to 0. So the answer will be, this will become 0, this will also become 0, 1 by 1, answer will be 1. Any problem? Any problem here? Again, you cannot apply L hospital rule. Is this form, can someone tell me, is it indeterminate form? Tell me, is this indeterminate form? We don't have to do and we don't have to check. I will not go there. I will just use my fundamental, and that is nothing but I will take the LCM, and here you can see that that will be x plus 1, x square plus 1 minus a x minus b, or This is the equation, right? So this is x square, so I will take the common of x square, that will be 1 minus a. Okay, now if I take common x, so this will be minus b, and here minus a, and what is the constant term? Constant term will be minus a. Yeah, there is no constant term. Yeah, there is a constant term, that is 1 minus b divided by x plus 1. Now I want to evaluate this. I want to evaluate this limit, and the value of limit should be such that the value is 0. So you can see that the power of numerator is actually greater than the power of denominator. The first what I will do is I will just divide numerator and denominator by x. So you will get and this will be 1 plus 1 by x, that is 0. Now you can see that I can get a finite value. When x will approach to infinity, this denominator will not be equal to 0, which means that if x is approaching to infinity, this term will become 0, but 1 will remain, which means that I will get a finite value, but that finite value will be equal to 0. Okay, so you can see that if I need that the value of limit is equal to 0, then you can see that here here a should be equal to 1, which means that this term should become 0. Otherwise the numerator will become infinite, but I need 0. So here you can see that a should be equal to 1. Okay, now clearly you can see that this term, what is the condition of this term and this term? What should be the condition of this term and this term? I need the value of limit 0. Tell me. This term should be equal to 0. You can see that this term also should be equal to 0. Otherwise, if it is not equal to 0, then it will leave a finite value other than 0, because this term is anyhow becoming 0, because when x is approaching to infinity, this term is about to become 0, but this term will remain, and that is not equal to 0. So which means that this term should also be equal to 0. So that's why this term will remain, then you will get a 0 value. So which means that if a equal to 1, then b should also, here you can say that nothing but a plus b equal to 0. So if a equal to 1, then b equal to minus 1. So the answer is a equal to 1 and b equal to minus 1. Is there any problem here? This is the very standard problem. GATE has never asked this kind of problem till date, but they can ask. I was speaking continuously. Okay, so did you solve this problem? Tell me, how many people are there? Sorry guys, actually I was thinking that I am teaching. Okay, fine.
Yes, sir.
Did you solve this problem? I explained that. I will not repeat it again. But yeah, I will upload this video so you can check that. Did you
Okay, sir.
try this? Okay, let's go to two more theorem and that's it. We are done. Exponential limit. And that is 1 by infinity form. Okay, so if limit x approach to 1, fx to the power gx lead to 1 raised to the power infinity, then we can use the formula that is limit x tends to a fx gx equal to e raised to the power limit x tends to a fx minus 1 gx. This is the formula. GATE has asked this on the basis of this formula. GATE has asked many problems. So what will I do is, first I will substitute x as a, and if you see the form is 1 raised to the power infinity, then you can directly use the formula as e raised to the power limit x tends to a and subtract fx by minus 1 and multiply that power in the function. Let's take one example. Suppose I have limit x tends to infinity 1 plus 2 by x raised to the power x. Then you can see that when you substitute x as infinity, then this term will become 0 and this term will become infinity. So that is nothing but 1 raised to the power infinity form. So you can use this formula. So what will I do is e raised to the power limit will remain same. Now I will subtract this function by 1. So you will get 1 by 2x minus 1 and I will multiply gx by this function. So you will get 1 will be cancelled out, and after this x will be cancelled out. So you will get e raised to the power 2. So that is the answer. So this is the one form. Take another example. Suppose I have limit x approaching infinity x plus 6 divided by x plus 1 raised to the power x plus 4. Then in this case also you can say that it is nothing but 1 to the infinity form, because when you divide numerator and denominator by x, then it will become 1 plus 6 by x and it will become 1 plus 1 by x, and when you put the limit it will become 1 and this will become infinity. So this is the 1 by infinity form. So what is the answer? Can someone tell me? Just take 1 minute, give me the answer. Are you guys here? Are you solving or not?
Solving, sir.
Yeah, tell me the answer. This is one example, and there is one more miscellaneous example I will solve in that sheet. What is the answer? Kalpana? What is the answer? A option, E, B option, E square, C option, E cube, D option, E raised to the power 5. Okay, let's solve this. Again, I will do the same thing. E raised to the power limit x approaching infinity. I will subtract this from 1. I will multiply this power in this function. That's it. Solved problem. So this will be, when you take the LCM, x will be cancelled out. This will become 5 divided by x plus 1 into x plus 4. Now this will be 5 times limit x approaching infinity, x plus 4 divided by x plus 1. Now you can see that there is another problem, and that is nothing but this. So just divide numerator and denominator. You will get 1 plus 4 by x divided by 1 plus 1 by x. And when you put the limit, this will become 0, this will become 0, the whole limit will become 1. So that will be e raised to the power 5. That is answer. Fine. There is one more problem, that is last problem using the series method. That is limit x approaching infinity, x minus x square log 1 plus 1 by x. You can see that this is also an indeterminate form, and that is infinity minus infinity. When you substitute limit, it will become infinity, this will become infinity, and you can see that 1 by infinity will become 0, so that is the log 1, that will become 0. So again this form is infinity by infinity. But the thing is, you cannot apply L'Hospital rule here. So there is one more way to do that, and you have to use the series So you know that 1 plus x of log x is nothing but that is x minus x square by 2 factorial, okay, plus x cube by 3 factorial and dot dot dot. Just substitute here. So limit x approaching infinity, x will remain as it is minus x square, and at the place of x it is 1 by x, so that will be 1 by x minus 1 by x raised to the power 2 divided by 1 by 2 factorial, plus I will not use this, I mean I can write it but they will not use of that. So you can see that, oh yeah, this is x only. So you can see that this is x minus x plus 1 by 2 factorial plus higher order terms of x square, sorry, not x square, 1 by x square, higher order terms of 1 by x. Okay, so x will be cancelled out and this will become 1 by 2 and higher order of 1 by x, and when you approach x to infinity the whole term will become 0. So the answer will be 1 by 2. So that's it, limit is over. Fine.
Yes, sir. So, can you show the that partial fraction of factorizing that in equation?
Which this one?
I mean, not this one. There will be two things, two method for, I mean, long division method for factorizing the equation, isn't it?
I'm not getting what you're trying to say.
I mean, if we are having a third or fourth powered equation, if we need to factorize, we can actually do the long division method, isn't it?
Oh, if it is required then you can use the binomial expansion. Okay, if it is required then you can use that.